All a sequence is it's a set of numbers that have some kind of pattern. So I would call this a sequence. 1, 2, 3, 4, dot, dot, dot. That's a sequence. That's a sequence of numbers. It's a pretty simple sequence. You guys can see the pattern to get from one term to the next. Okay, that's a sequence. Okay, give me another sequence that you guys might be able to come up with.
2, 4, 6, 8.
2, 3, 1, 3, 5, 7,
10, 20, 30, 40, 50.
1, pi, 2, pi, 2, pi, 3, 3,000.
Okay, so you guys got the idea, right? Okay, so those are all sequences. What about like 1 and then 4 and then 9 and then 16?
3.
Is that okay? Everybody kind of see what that sequence is, maybe? What kind of numbers are those? Squares. Those are squares, right? So the sequence for that would be a square. Okay, so the first term would be 1 squared. Second term would be 2 squared, 3 squared, 4 squared, all the way down the list. Okay, so these are all sequences. Okay, and the sequence has what they call. First off, for a pattern, for you guys to develop a pattern, you need at least 3 terms. Okay, if you don't have 3, then we can't really develop a pattern. Okay, for example, I can give you this pattern right here, and then dot dot dot, or I can give you this pattern right here, and then dot dot dot, and they can be 2 completely different sequences, right? I can do 1, 2, 3, or I can do 1, 2, 4, 8. Right? So there's different sequences you can have, just depending on how many you start. Now, I think you need at least 3. 4 is good, but 3 is like the bare minimum in order for you to see what the pattern is going to be for your sequence. Okay? Everybody okay with that? That's not too bad? Now, for a sequence, the sequence has what they call the nth term, okay, or the term for the sequence. And that we usually write as a sub n. Okay? A, the lowercase a, is going to denote a term in this whatever sequence it is, and then n is going to denote the number it is in the sequence. So if I want a sub 7, that means I want the 7th term in the sequence. So if my sequence happens to be 1, 2, 3, 4, 5, 6, 7, 8, 9, dot, 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 right, there's my sequence. The 7th term is this guy right here. The 7th term that's in the sequence. Okay? If I want a sub 8 for whatever that term is, I want the 8th term. Okay, and that works for any pattern. Doesn't have to be just 1, 2, 3 all the way through. Okay, now the a sub n is what our general formula is going to be. Okay, so let's say I give you a general formula. Let's say I said a sub n equals 3n plus 1. Okay, that's our a sub n term. That means that any term in the sequence, I can write it in this format right here, in this number. So let's say I wanted to find a sub 1. A sub 1 would be the first term in that sequence. That's what that little 1 stands for. Okay, so all we have to do is plug the 1 in for the n. Okay, so we plug the 1 in for the n right there, and what do we get? We get 4. Good. So the first term in this sequence is 4. Okay, we're okay with that? The second term in this sequence, you just plug in a 2 now. And that would be the second term in the sequence. It would be 3 multiplied by 2 plus 1. I'm literally just replacing the n with whatever I replaced with the n right here. Okay? So I have 3 times 2, which is 6, plus 1, so I get 7.
So is that number always going to be the number?
This number right here is going to be the term of the sequence. So let me do the next one, and maybe let me do 2 more.
Will it be anywhere in the? Can it be located anywhere in the?
Anywhere in there, right? Could be in it, right? So let's say we did a sub 3. Okay, now a sub 3 is the third term of the sequence. I'm going to plug a 3 in for the n, so I'm going to plug a 3 in right there. So it's going to be 3 multiplied by 3 plus 1, and we get 10. Now, once you get 3, you might start to see the pattern and then not have to plug stuff back in. You might just be able to cheat a little bit and say, all right, what do you guys think the next one's going to be? 13. Okay, so you can kind of see that general idea of that sequence. Now, if I look at that sequence, my sequence is 4, 7, 10, 13, dot, 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 dot. Okay, and it would be 16 actually, right?
Yeah.
Okay, good. Awesome. Okay, so there's my sequence right there. Okay, is everybody okay with that? Now, the a sub 1, that's the first term in the sequence. So out of all these numbers right here, a sub 1 is the first term, which is a 4. A sub 3 is the third term, which is 10. Okay, so that's how you kind of reference those terms. Okay. Now, a couple of small differences. One, this goes dot dot dot. It goes forever, right? So this they call an infinite series. Okay, it goes on forever, infinite. A finite series would be, let's just cut it off and stop it right there. You can still have a series just enclosed at whatever section you want. I'll show you kind of how those are all going to happen. Most of them we're going to deal with infinite series, or infinite sequences, but yeah, should be good. All right, so are we okay to start right there? Now, an arithmetic sequence, let's take a look at an arithmetic sequence, which is the title for the day. And you guys mostly did arithmetic sequences just when I said, hey, what sequences do you guys know? Most of you guys already did that automatically. So arithmetic sequence is 1, 2, 3, 4, dot, 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 dot. It's an arithmetic sequence. Another one you guys have was 2, 4, 6, 8. Dot, 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 dot. Okay, we did 1, 3, 5, 7. Okay, so what do all those guys have in common? They increase by a certain amount every time. Okay, that's the most basic thing I can do. Arithmetic to me seems like it should be fairly basic, right? So arithmetic is you're adding the same number to get to something every time. So for this one, I would have what they call a common difference. Okay, so on arithmetic, you're going to have something called a common difference, which basically means, and I usually write it as a D, whatever our common difference is, it's whatever number gets us from one term to the next term, that term to the next term, that term to the next term, so on and so forth. Okay? So the common difference for this one, for my first one, my common difference would equal 1, because I'm adding 1 every time on the sequence. Okay? On the second one, 2, 4, 6, 8, my common difference here was 2. Okay? I added 2 to it every time. Okay? The last one was, once again, common difference of 2. Okay? Now, anytime we want to write an arithmetic sequence, basically we're adding the same number every time. So it's a very linear concept. Okay? If I were to graph these points as ordered pairs, it would be linear. Okay? I go over an equal amount, I go over a term length, and I go up the same distance. Go over a term length, go up the same distance. So it's linear. Okay? So if I want to write an a sub n term for an arithmetic sequence, it's basically going to be a line. Which, for a line, what's an equation of a line? mx plus b. Okay? M is the slope, x is our term value that we're plugging in, and then b is our y-intercept. Now, as far as the a sub n formula goes, it looks like this. It's going to be dn plus c. Now, in essence, this is y equals mx plus b. This is our value after we plug stuff in. D is our common difference. It's kind of like your slope for this. M is going to be the value you're plugging in, right? That's that value right there. And the c is kind of like your y-intercept. Where the heck does this guy start? Okay? So let's say I start with a sequence 1, 3, 5, 7. 1, 3, 5, 7. And I want to write what they call the apparent nth term. I want to write the nth term for this sequence right here.
So that equation is to work backwards?
Yes. It would be this. If I said, for this sequence right here, what's the 100th term in this sequence right here? Would you want to write out all 100 terms to find out what that is? No. You need to figure out some formula that you can plug 100 into and then get that term, whatever it happens to be. Okay? So, if I want to write the a sub n term for this sequence right here, first off, I need the common difference, which is 2. Okay, so I have a sub n is going to equal 2 multiplied by n plus c. Now you want to solve for the c value. And the c value, there's a couple ways to do this, but I like to plug values in. For example, if I had a sub 1, right, that means I'm plugging a 1 in for n. Right? I know what the first term is. The first term is 1. Right? So a sub 1 equals 2 multiplied by the n value. Now the n value I'm plugging in is this 1 right here. So 2 times 1 plus c. Now the a sub n term, the a sub 1 term, we know what that equals. That itself equals 1, right? So this equation is going to equal 1, which now we'll be able to solve for c. We'll be able to find out what that difference is. Okay, so I have 2 plus c equals 1. I'll move the 2 on the other side. C is a negative 1. So my apparent nth term for this one, we'll do a couple of these, so if you didn't catch that right away, it's okay. We'll do a couple of these. My a sub n term, my apparent nth term, is going to be 2n plus c, so it's going to be a 2n minus 1. That right there is my apparent nth term.
How'd you get that it equals 1?
Because this right here is a sub 1, a sub 2, a sub 3, a sub 4, right? And so I just said a1 equals 1, right? I could have picked a2 equals 3 and a3 equals 5. I could have picked any one of them, really. It doesn't matter. But I just picked the first one because it's usually easier. So we got 2n minus 1. That's my apparent nth term. Now if I want to find a sub 100, I want to find the 100th term in the sequence. Instead of writing all the terms out, I can just plug in 100 into this nice new formula that I have. I go 2 multiplied by 100, take off 1. So I get 200 minus 1, so I get 199. So the 100th term in that sequence is going to be 199. Make sense? Not too bad. Okay, let's do one more of those. Actually, probably 2 more of these. Just till we get the hang of it. All right, so let's say we have the sequence. Let's say we go 3. Okay, and I want to find a sub 37, my lucky number. Okay, so I want to find the 37th term in this sequence, whatever it happens to be. First off, it's a good idea to identify what kind of sequence it is. This one is going to be arithmetic, and that's the only one you have right now. So right? Because we just started. So this one is arithmetic because it has a common difference. So we want to find our common difference first. It's going up by a certain value every time, right? It's going up by 3. So my common difference is 3. My general formula that I plug in, a sub n is going to be dn plus c. And I'll show you kind of a shortcut maybe on this instead of the whole solving thing, but yeah.
Are they going to have problems where they have gaps?
We are.
Okay.
We're getting there. We're about to hear on the notes. So we got.
Are you serious?
I actually wrote all the notes out. Like I actually did it all. I almost never do that. So we're doing fine. We're good. Okay, so first thing you want to find is the nth term, the a sub n term, the apparent nth term. Those are all different the vocab that they'll use here. Okay, so first I'll find the common difference, which is 3. So a sub n is going to equal 3n plus c. Now on this one, what I like to do, I like to do it pretty quick here. I like to say, all right, well, I have 3n plus c, and if I want to get to the first term, I just figure, all right, well, if I go 3 plus what number is going to give it to the first term? Well, that's going to be 0, right? So the c value on this one is 0. So my a sub n term is just going to equal 3. And I did that more or less based on a guess and check. If I were to plug in a 1 right here, do I get the first term? I do, okay? Now, if you didn't get that, the long way to do that is to pick one of those terms. For example, this is a sub 1. So plug in a sub 1 equals 3 times n value is 1 on this one plus c. Okay? Now we know a sub 1 equals 3, right? So we have 3 equals 3 times 1 plus c. Now I can solve for c. C equals 0.
I don't get why a sub 1 equals 3.
Because a sub 1 right here.
Oh.
The first term. It's kind of weird. It's kind of weird just the way that they write this. A just stands for each individual term. The 1 is like the value you're plugging in, and then 3 is what the term itself equals. So that tells you where to put stuff. Okay.
What if it was 6?
Like if this first term was 6?
Yeah.
That's fine. You would still have a sub 1 right here. You would have just plugged in a 6 right here. I'm sorry. You would have plugged in a 6 right here for a sub 1 instead of 3. Basically, just that number will change. Okay? Now, that means my a sub n term equals 3. And you can double check this, okay? If I were to plug in a 2, right? What's 3 times 2? 6. That's my second term, right? Plug in a 3. That's my third term, right? 3 times 3 is 9. That's my third term. Plug in a 4. That's my fourth term. So you can double check on your first couple just to make sure you got your sequence right. Okay? So it's kind of nice as far as that goes. Now, if I want to find a sub 37, the 37th term here, I just go 3 multiplied by 37. And I get something big. We got that one. Is that 111? Okay. So the 37th term would be 111. Everybody okay so far? Nothing earth shattering? Okay, let's go ahead and make it a little more complicated now. And then we'll work on finding what they call series. Slightly different than a sequence. Oh, we're doing so good. Okay, let's say find a sub n if the fifth term is 19 and the ninth term is 27. And I will tell you it's arithmetic. If they don't tell you that, it's kind of hard to do. Okay, we'll do this and then we'll switch gears to some series. Some serious series. My mouth hurts. I'm still a comedian.
I didn't know what the first one is.
Do you need the first one?
Don't you need 3?
I'm telling you it's arithmetic. So that takes that part of it out of it. But you would need 3 to see the pattern. Yeah. No. We're looking for a sub n. That's what we're looking for. We'll find a sub n, find the nth term for this, the apparent nth term. I think I did that right. 5th, 6th, 7th, 8th, 9th. Just making sure. Now, I tell you it's arithmetic, which means we can jump right to this formula. We know it's going to be a linear type equation, so it's going to be dn plus c. That's what we're looking for is dn plus c. Now, we need to figure out what our d is. We need to figure out what our common difference is going to be. Now, if you notice here, I've got from 19, I'm going to add a common difference. I'm just going to put a little plus d right here. To get to this term, I have to add d. To get to this term, I have to add d. To get to this term, I have to add d. This one to add d, right? So how many differences do I have there? 4, right? I added 4 differences to get from here to here. Notice we have the 9th term and the 5th term. If you subtract those, that means that there's 4 differences between those, right? If you take 9 minus 5, okay? So I have 4 differences. 4 differences is going to equal whatever the difference is between these two right here, right? So if I go 27 minus 19, that gives me 8, which means my common difference would be 2. Okay, and you could always double check that. If you add 2 to this, that would make this 21, 23, 25, 27. You did it right. Okay, so we checked it as far as that goes. So we know our common difference is 2. And all I did there, just to double check real quick here again, is I took the 9th term minus the 5th term. That told me there was 4 in between there, 4 left over. So there was 4 differences for that. That's why I picked the 4 right there. 27 minus the 19, take those off, that means the difference between these two is going to be the 8. That's why we divide by 4, we get a difference of 2. Okay? Now, are we okay on that? Right? Okay, now if we plug it in, right, we've got to plug in our difference right here, which is 2. My a sub nth term is 2n plus c. Okay, so now I just got to find out what my c value is. It feels very similar to that y equals mx plus b idea we were doing, right? So now I got to pick one. Well, you can pick whichever one you want. I would probably pick one of the ones that I gave you, just because if you screwed up the other part, then you're going to mess that up too. Oh, you already know it's 5.
No, I'm saying plug in 5.
Oh, you're saying plug in 5. Yeah. This term right here is the 5th term, right? That's essentially a sub 5. Right here is the 5th term in the sequence, and that 5th term equals 19. So if I go a sub 5, I'm plugging in the 5th term, which I know equals 19. I know the 5th term is 19, so I know that those two are equal to each other. Okay? So as I plug in the 5 in for n right there, I've got 2 multiplied by 5 plus c, so I've got 10 plus c. And subtract, so I get 9 equals c.
So since it's a 5th term, you don't plug in 19, you just plug in 5.
Well, right, because notice that n right here replaced the 5, right? So that's why I plugged the 5 in for n. And the whole term here I replaced with 19 because the 5th term is 19. Okay? So there's 2 different substitutions you do in here. You just got to watch out, be careful which one you're doing for. Okay, so we got our c value is 19. That means that my formula here is a sub n equals 2n plus 19. Right? Is everybody okay with that? Now you can double check that, right? Plug in a 5, no, plus 9. What am I doing? 19? Retardo. Plug in a 5 real quick, right? So 2 times 5 is 10, plus 9, 19. Got it, right? Now the other one they gave me this guy right here, right? The 9th term was 27. So if I plug in a 9 right there, it should give me 27, right? So plug in a 9, 2 times 9 is 18, plus 9, 27, jackpot, we're free. We feeling okay about that? That's pretty straightforward? I hope. Yes, good. You came in halfway through, so that doesn't count. All right, let's change gears. Let's go to series now. I think you guys are all good with sequences. What? You've been talking the whole time anyway, so why are you acting like you're bored?
I'm not bored, I'm just like...
The series, like, where they, like, have different...
That is what they do.
What did Ron explain it?
I will tell you.
Like, one will be like plus 2, one will be the next one will be like plus 3.
Oh, no. No.
That's not arithmetic.
That's not arithmetic, no. Unfortunately. That's for later. No, unfortunately. All right, so first up, we have a sequence, right? And we can come up with any sequence we want. So let's go real basic on this one. 1, 2, 3, 4, 5. Even sturgeon can do that sequence. It's awesome, right? What's the next term here? See, you can do it. Awesome. Welcome to the class. Perfect. Okay, now a series. Please. Gentlemen. All right, now a series. The only difference between a sequence and a series is this series right here. All we're going to do instead of writing those numbers in a sequence, we're going to take those numbers, we're going to erase all those comma signs, and we're going to put plus signs in. And we're going to add those numbers up together and see what we get. That's what they're going to call a series. A series is a sequence of numbers that you're going to add together. So we're going to add all those numbers together.
It's like the bonus on the test.
This is eerily similar to the bonus on the test. Interesting.
Bonus on the test was
Bonus on the test from last chapter? Yeah.
Those are so ridiculous.
That was a series.
Like for a second, I was like, what? It was like
I know,
It was
I know.
8,540.
Yeah. I don't remember what it was. I'll have to take a look. All right, no. Shh. Now our series is just adding those numbers together. Now this is still going to be whatever a sub n term is. Thank you. Okay, so we have an a sub n term that gives me each individual term here, but now I'm adding those guys together. Now the notation for this, the notation is what's called a sigma notation. And what they have is they have a little bracket in front of it that looks something like that. If you want to get super fancy, they look like this. Have you seen those?
Yeah.
That's the sum. Oh, what do you know? We're adding those together. The sum. Interesting, okay? So you're going to take what they call, this is actually called a sigma. Okay, this is called sigma notation. And if you go to college, which hopefully most of you do, and you learn a little bit about the Greek system. Anyways, all right, so this is the sum right here. Now, the different notation for this is this. The a sub n term is going to go right on what they call the inside of that series, or the inside of that sigma notation, the inside of that series. Okay? Now, they have what they call an upper and lower bound. Basically, it's like where we're starting and where we're finishing. Okay? So the bottom right here, we're going to say n starts at 1. And on the top, we're going to say where we're going to stop. So let's say we want to stop at 4. I'm totally making those up. And let's say our a sub n term, is going to be, and I hate making these brackets all fancy. I'll end up scribbling them later. Let's say we go n equals 1 to 4. And let's say our a sub n term is 3n plus 1. Okay, this means this is my a sub n part of it. Okay, that's what that is. First thing you want to do is write out the series. If I start at 1 here, this is called your lower bound, okay, your lower limit. I want to plug in a 1 right there and see what I get. Well, if you plug in a 1, what do you get? 4. So the first term there is 4. Plus, we want to now bump that up by 1. So instead of being a 1, now we're going to go to 2. So plug in a 2 there, and what do you get? 7. Okay, now take the next number, right? The next number is 3. So I'm going to plug a 3 in there when you get 10 plus, oh, we're up to our upper limit, up to 4, right? It's just like our other one. Plug in a 4. 4 is 12 and 1 is 13. So we get 13. Okay? Now I add all those numbers together, and that'll give you the series. Okay, the series is those numbers added together.
Whoa.
34.
I feel like that's what I'm doing. Rhyme or reason.
Oh, for rhyme or reason for what? Oh, you want a real world example? There's one coming. That'd be great. Maybe. All right, now this one is a sum. They call it a partial sum. The reason they call it a partial sum is because you're only doing a part of the sequence. We're only going from 1 to 4. Now, I could have done any which numbers there. I could have done 1 to 40 or 1 to 400, and that would just take a long time to do, right? So there's other ways to do that. The catch here is this. If I were to take a look at these two numbers right here, the 4 and the 13, right? What's the average of 4 and 13? I should have picked better numbers. 17 over 2. 17 over 2, right? What's the average of these two guys right here? 17. Oh, it's the same number. That's kind of cool. And I wonder if that'll be the same as I continue that series all the way through. It ends up it will. Okay, the outside ones are always the average, so the same average all the way throughout the middle. That means that the sum of a partial arithmetic sequence looks like this. If I want to do the sum of the first n terms, okay, that's an S for sum. Okay, so the sum of the first n terms right here, if you notice that the first and the last term right there, if I were to average those two, everyone in the middle right there has the exact same average. So if I take that number, that average, and I multiply by how many numbers are in the sequence, that'll give me the sum. So if I take the average of the first plus the last, that's the average, right? First term of the sequence plus the nth term, wherever we decide to stop, divided by 2, that's the average of the outside number. If I multiply that guy by n, that'll give me the sum for that series. Very cool. So, let's say I gave you a partial sum. Let's say I say n goes from 1 to, let's go 40. And then let's do a 2n minus 5. No, 2n plus 5. So I want to do this partial sum. Now, I don't want to write out the first 40 terms of this sum. That would be ridiculous, right? Plug in a 1, it'd be 7, plus plug in a 2, well, you can see it's arithmetic, so we're going to add 2 every time, right? So it's going to be plus 9, plus 11, plus 13, plus dot, 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 dot. It's going to be plus all the way to the first 40 terms. Nobody wants to spend their time doing that, okay? So let's not. Let's use this sum formula right here and figure out what it's going to be. Now, I want to find the sum of the first 40 terms. So if I want to find the sum of the first 40 terms, it says take the first term. What's the first term in my sequence? A sub 1. 7. Plus the nth term. Now, I want a sub n is now 40. Okay, notice I plugged in a 40 for n. So I want the 40th term right there, right? So what's the 40th term in this sequence? Well, I'll just plug 40 in, 85. So I get 85 for the 40th term for that. Divide that by 2, and then multiply that by how many numbers are in the sum. That's 40. Multiply all that together. That'll give me the sum of the first 40 terms without actually having to compute all of those.
Wait, I'm confused. Why ace couldn't be
Remember, it's s sub n, right? So n now equals 40. So basically, everywhere I see an n, I put a 40. Okay? So I put a 40 for this guy and a 40 for this guy. So that's why that's 40. And then a sub 40 is the 40th term in the sequence. So I plug in the 40 here to my a sub n. Okay? I did a couple of those steps without writing it down. But the 40th term there would be 85. A sub 1 is always the first term in the sequence. You just plug in the second. Okay? So what did you guys get for your sum, your partial sum there? 1,840? Okay, sounds pretty good. Okay, we okay? It's not too bad? Okay, now let's say we want to count the number of seats in an auditorium.
Oh, this is real life.
This is totally right. I would totally want to do that.
Well, if you want to know your seating capacity, or if you want to know how many seats you fit in a certain area, you would count? You would seriously count? This is similar. Each person occupies a space, and you figure out space. Maybe one or two.
To do this, that's cool.
Amen.
What does that have to do with
Stephen, didn't that match your? That was good. Now, for some people, it might be beneficial to actually write out part of the sequence, or maybe even part of the sum. But part of the sequence, first row, we're saying has 30. Now, I don't want to write them all out, but basically you have a row of 30 in here. And then your next row is going to be a little bit bigger. It's going to be 32. That's going to be your next row. And then 34, right? And then the next row,
Are we starting with this?
36, da 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 da. Okay, well that right there is your sequence. Okay, that's not the series, that's the sequence. Now I want the sum of the first however many rows that I have. So I'm looking for the sum. Now I have 40 rows. Okay, I have 40 of those rows, and I don't want to have to add all 40 of those together. But I'm finding the sum of the first 40 rows. Okay, so my sum for the first 40 rows is what I'm solving. Okay, so that's what I want for my final answer. What might be nice is writing our a sub nth term, our apparent nth term for this one, which is going to be dn plus c. Okay, now our common difference is 2. So our a sub n is going to equal 2n. And like I said before, I like to think if I plugged in a 1 right there, what I would have to add to get to that first row, right? Well, the first row is 30, so I'd have to add 28 right here. 28 plus if I plugged in a 1 right there, 28 2 gives me the 30. Okay? If you want to do what you did before, where you plug in a sub 1 and you plug in a 1 there and solve for c, that's fine. I like that kind of shortcut there for myself. Okay, now that's my a sub n formula right there. Okay, so essentially what I'm finding is I'm finding the sigma, the sum, as n goes from 1 to 40, first 40 rows of 2n plus 28. Okay, that's what I'm solving for. The sum of the first 40 terms in this partial sum.
All right, let's see it again.
N's where it starts. The only reason I put the n down there is so that the variable agrees. So they just tell you what variable you're plugging in for, essentially. Starting at 1, going to 40. Okay?
Wait, we just went higher up to 28.
If I were to plug in a 1 right there, what's 2 times 1? 2, plus what would I have to add to get to 30 for my first row? 28, right? So that's where I got the 20.
Yeah.
Okay? Because I know if I were to plug in a sub 1, a 1 right here would give me 30, and that's my first row. Now, like I said, what you could do, you could say a sub 1 equals 2n plus c, which is what we did before, and a sub 1 equals 30. So 30 equals, and then you would plug a 1 in for n, so it'd be 2 times 1 plus c and solve for c there.
Okay, that makes sense.
Just a little more work, but you can always do that. You can just fall back to that. Okay? All right, so my sum, now I jump to my sum formula. Now my sum formula of this is going to be a sub 1 plus a sub 40 divided by 2. And I'm going to multiply all of that by 40. So I ran out of room here. So I'm multiplying that, and that looks like power. Okay, so my sum for my first 40 terms is the first term in the sequence, which is 30, plus the 40th term in the sequence. So maybe it might be good to find the 40th term here, right? So plug in a 40. 40, 80, 108. So there's going to be 108 seats in the last row. Divided by 2, multiplied by 40. How many seats do we have?
2,160.
2,760.
Wow. Oh,
Yeah, your math was wrong.
I'm just trusting you guys on that one. Oh, actually, I wrote, I already got that. Yeah, I used my brain. Got it.
And he's captured.
Which naturally means I'm smart.
We got 11 minutes to do this.
You can get started on it, yeah.
Whoa, this seems
Oh, easy.
Oh,